record, present my screen. And start my document camera. You got your science book, Kale? Jacob, you looking at your science book? Jacob, you looking at your science book? Kale, can you open your science book, please? To 490. Okay, page 490. Mixing it up. How is energy transferred to the sun's surface? I think it looks better when it's over here. Energy is transferred to the surface of the sun by two different processes. Energy that is transferred from the sun's core through the radiative, whoops, you okay? Radiative zone is transferred by the process of radiation. Energy that is transferred from the top of the radiative zone through the convective zone to the photosphere is transferred by the process of convection. Energy flow from the sun's core outward to the sun's surface by radiation and convection happens continuously. So this is the core here, right? And then this is the radiative zone. And this is the convection zone, right? You can see it by these little circles because it heats up and goes down. And this is the photosphere. P-S-P-H-E-R-E. Okay. By radiation, when energy leaves the sun core, it moves into a radiative zone. Energy travels through the radiative zone in the form of electromagnetic waves. The process by which the energy is transferred as electromagnetic waves is called radiation. The radiative zone is densely packed with particles such as hydrogen, helium, and free electrons. Therefore, electromagnetic waves cannot travel directly through the radiative zone. Instead, they are repeatedly absorbed and re-emitted by particles until they reach the top of the radiative zone. Okay. By convection, let me move this over so you can look at that. By convection, energy that reaches the top of the radiative zone, which is right here, is then transferred to the sun's surface in the convection zone. Energy is transferred by the movement of matter. Hot gases rise to the surface of the sun, cool, and then sink back into the convective zone. This process in which heat is transferred by the circulation of movement of matter is called convection. It's the same thing. It's the same thing you see when you boil a pot of water on the stove, right? Because the water at the bottom of the pot gets heated up, it comes up to the top, it cools, it goes back down, it gets heated back up, it cools, and you have that cycle. That's what convection is. Convection takes place in convection cells. A convection cell is illustrated on the opposite page. So this is, we'll get over here. Convection cells form granules on the surface of the sun. Hot, rising gases cause bright spots to form in the center of the granules. Cold, sinking gases cause dark areas to form along the edges of the granules. Once energy reaches the photosphere, it escapes as visible light, other forms of radiation, heat, and wind. I'm going to underline that. Once energy reaches the photosphere. Okay. Energy is transferred from the sun, and here's our diagram. Okay, that's bottom 490. 491. Let's get this. Okay. The top of the convection cells form granules on the sun's surface. That's what it looks like. Hot rising gases and colder sinking gases form convection cells in the convection zone. So this is the surface. This is what it's looking like, but this is coming up, coming back down. This is the dark areas here. Okay. So it says, how does the sun rotate? The sun rotates on its axis like other large bodies in the solar system. However, because the sun is a giant ball of gas, it does not rotate in the same way as a solid body like Earth does. Instead, the sun rotates faster at its equator, which is right here. This is the equator. Which is the middle. It has the root word of equal, right, or middle. Than it does at higher latitudes. This kind of rotation is known as differential rotation. It is the rotation of a body in which different parts of the body have different periods of rotation. Near the equator, the sun rotates once in about 25 days. So you can see here in the equator, it rotates every 25 days. However, at the poles, the sun rotates once every 35 days. So here's the pole. Even stranger is the fact that the sun's interior does not rotate in the same way as the sun's surface does. Scientists think that the sun's core and radiative zone rotate together at the same speed. Therefore, the sun's radiative zone and core rotate like Earth. So inside, it rotates together. And then on its surface, where you have all this gas, right, it rotates at a different thing. Okay. Number 14. Let's fill out. Bless you, bless you. God, we all got all kinds of sneeze and coughings going on. Okay, so number 14, radiative zone is electromagnetic waves. We're going to write, oops, let me move it over, sorry. Electromagnetic waves repeatedly absorbed and re-emitted. Okay, convective zone, movement of matter through convection cells. Hot gases rise, cool, sink, back into convection zone. Okay, number 15. At the bottom, we have, in your own words, define the term differential rotation. So it's the rotation of a non-solid body different periods of rotation occur at different latitudes. Okay. Okay, moving on to the next page. 492, the Ring of Fire. Okay, what is solar? Oh, yep, Ring of Fire. What is solar activity refers to variations of appearance of energy output of the sun. Solar activity includes dark areas that occur on the sun's surface known as sunspots. Solar activity also includes sudden explosive events of the sun's surface, which is called solar flares. Prominences are another form of solar activity. Prominences are vast loops of gases that extend into the sun's outer atmosphere. Sunspots, dark areas that form on the surface of the sun, are called sunspots. They are about 1,500 degrees Celsius cooler than the areas that surround them. Sunspots are places where hot, convecting gases are prevented from reaching the sun's surface. Sunspots can appear for periods of a few hours or a few months. Some sunspots are only a few hundred kilometers across. Others have widths of up to 10 to 15 times the diameter of Earth. Wow. Sunspot activity occurs on an average of 11-year cycles. When a cycle begins, the number of sunspots is at a minimum. The number of sunspots then increase until it reaches a maximum number that begins to decrease. A new sunspot cycle begins when the sunspot number reaches a minimum again. Okay. So 16 says the sunspot range is the difference between the maximum number of sunspots and the minimum number of sunspots for a certain period of time. To find this range, subtract the minimum number of sunspots from the maximum number of sunspots. What is the range of sunspot activity between 1700 and 1800? So if we're looking at 1700 to 1800, right? Subtract the minimum number of sunspots, which is 0, right? Which is here, 0. From the maximum number, which is 150, right? Because that's your biggest number up here. So 0 minus 150 is 150. Okay. Okay, over here to the right, you have another picture. It says sunspots. This is a sunspot. Solar flares. This is a solar flare. It kind of looks like a fountain. And prominences are three kinds of activity that occur on, and this is a prominence. It kind of looks like, the arch in, where's that place? Cleveland? Is that Cleveland, Ohio, where that arch is? Maybe it's not. Is it Ohio? No, I don't think so either. I'll look it up. But you can see the Capitol building, you can see the arch behind it, right? I'll have to look it up. Yeah, it's a pretty amazing, and you can take an elevator all the way up. Pretty cool. Okay, 493, solar flares. Solar flares appear as a very bright spot on the sun's photosphere. A solar flare is an explosive release of energy that can extend outward as far as the sun's outer atmosphere. During a solar flare, enormous high energy particles ejected at near the speed of light. Wow. Radiation is released across the entire electromagnetic spectrum, from radio waves to X-rays to gamma rays. Temperatures within solar flares reach millions of degrees Celsius. Prominences, this is a prominence, huge loops of relatively cool gas that extend outward from the photosphere thousands of kilometers into outer atmosphere are called prominences. Why didn't I underline that? Huge loops of relatively cool gas. Okay, several objects the size of Earth could fit inside, so Earth could fit in that loop. The gases in prominences are cooler than the surrounding atmosphere. Prominences generally last from several hours to a day. However, some prominences can last for as long as several months. Wow. Okay, so then we got our Venn diagram. So solar flares are very bright. Explosive release of energy. Millions of degrees, millions of degrees of temperature. And radiation is released. Radiation is released across, entire electromagnetic spectrum. Radiation is released across the entire electromagnetic spectrum. Move that up for you a little bit. Okay, for both occur at the sun's atmosphere, occur in the sun's, both of these occur in the, sun's atmosphere. Okay. Prominences, huge loops of gas that extend outward. Huge loops of gas extend out to the atmosphere. Gases are cooler. Yes, sir? Of course you can. Gases are cooler. Can last from hours to a day. So prominences, both solar flares. Okay. Okay. Everybody. Okay. Turn the page. 494. Visual summary. Number 18. Okay, the sun is located at the center of the solar system. What are the paths of the objects around the sun called? Orbits. 19. The sun is composed of layers. Identify the 6 layers of the sun beginning with the innermost layer. Okay, so you have the core. You have the radiative zone. You have the convective zone. You have the photosphere. You have the chromosphere. Chromosphere. P-H-E-R-E. I just made it. Chromosphere. And last but not least, the corona. Okay, energy is transferred from the sun's core to the photosphere. 20. By what process is the sun's energy transferred in layer A? Oh, here's layer A right here. So layer A is radiation. Radiation. Oops. Radiation, radiation, and B is convection. Convection. Okay. 21. Describe in your words. Describe the process of energy production by nuclear fusion in the sun. Oh my gosh. You know what? We're just going to say here, this is a 3-step process. Okay, and it starts with deuterium. So it starts. So we're just going to go. It starts with deuterium, right? And then you got helium-3, and then helium-4, and then you get helium-3, helium-4. Okay, we'll just keep it simple. Okay, page 495. Question number 1. Fill in the blank with the term that best completes the following sentence. The process by which 2 or more low-mass atomic nuclei are fused to form a heavier nucleus is called, and that's going to be on page 488. This is 488. A blank is the dark area on the surface of the sun that is cooler than the surrounding area. And that is on page 492. Number 3, a blank is a loop of relatively cool gas that extends above the photosphere. That's going to be page 493. Okay, key concepts. In the following table, write the name of the correct layer next to the definition. Okay, so we're talking about the layers of the sun, I'm sorry. So let's see, what page would that best be? That would probably be 487. 487 will be the best page for that. Number 7, describe what is the composition of the sun. Well, let me see. Yes. 486. Page 486. You watching your book? Number 8. Describe what is the universe. Where in the universe is the sun located? Well, that's at the beginning of the chapter. So that is 484. 484. Okay, use the illustration to answer the following questions. Number 9, determine how many days does it take for the sun to spin once on its axis at location A. How many days does it take for the sun to spin once the axis at location B? So that is on page 491. Number 10, compare. How is the rotation of the sun different from the rotation of the earth? Okay, well, that's going to help you. Page 491 also. Okay, number 11, explain. In your own words, explain how energy is transported from the core to the surface of the sun by radiation and by convection. So that's going to be page 490, we'll say. Okay. Yes. Number 1, 488. I'm going to try to see if I can get this to. What happens if I go like that? Does that help? No. What if I go like? I guess I'll just have to move it for you. Okay, so 5, 10, 15 minutes left. Okay. I think you can do that fairly quickly. I would definitely fill in your page, or if you want to go to the quiz, you can go to the quiz. Okay, well, you're working on your quiz? Quiz? Working on your quiz? Yeah. Yes, ma'am. Thanks. Awesome. Awesome. Yep, we'll do that on Thursday. Do that tomorrow. Two. Virtual. Gustavo is here. Bless you.
Ow, I bit my tongue.
Oh.
Ow, that hurt. Ow.
Yes, ma'am.
You make it to where you can take the quiz, where you can retake the quiz.
I
got the second to last question wrong.
let me. I thought it. Let me. I'll check that for you. I thought I set it up that way, but I'll fix it for you. Okay, I fixed it.
It's
So you're gonna retake the quiz.
oh, it's seriously.
Mm-hmm.
What page is question 11?
490.